Hey guys, for the depth study, I decided to experimentally determine the gravitational constant, g, which is found in Newton's formula for universal gravitation, where g represents the gravitational constant, F represents the gravitational force, m and m represent the masses of the two bodies, and d, which represents the distance between them. As it turns out, gravity exists not just between planets, stars, and galaxies, but between anything with mass, from as small as a proton to as large as the sun. Thus, I decided that if I could find the force of gravity between two masses at a set distance, I could find the constant. But gravity is a very, very weak force, more than 100 billion trillion times weaker than electrostatic force. So, to do this, I conducted what's known as the Cavendish experiment, which was first conducted by Henry Cavendish in the late 18th century. Shown here is my experimental setup. A wooden plank is placed on a stack of chairs as far apart as possible, and a string is attached on it at the center. A meter-long ruler is attached to the other end of the string also attached at the center of the ruler, and two half-a-kilogram masses, 500 grams, is taped on either end of the ruler with lots of tape. This is known as a torsion balance. Before continuing with the experiment, I placed a protractor that was printed out under the center of the ruler as accurately as I could, and I let it sit for 15 minutes or so to make sure that if the wire was twisted, it will undo itself and sit very still for the experiment. Upon reflection, I should have waited a lot longer. Then I got two large masses, 32 kilograms weights from PE, and placed them 30 centimeters perpendicular to the ruler. What happens is, the gravitational force applies a torque, a turning force, causing the ruler to rotate. The string starts to twist, and as it becomes more twisted, it wants to untwist by a principle called torsion. And when it twists enough, it overcomes gravity and starts rotating in the other direction. Just like that, it's oscillating. If I measure the period of oscillation, or the time it takes for it to reach the same position again, and the overall change in angular displacement, I can find the force of gravity applied to the small masses and thus the gravitational constant, as per the complicated formula on the screen. Unfortunately, there are a few problems. Gravity is incredibly weak, so any disturbance, such as a magnet, since the masses were likely magnetic, or any object in the room at all, including myself, will affect the contraption. Any airflow, even from me simply moving, will affect it. Once, as shown here, the ruler just kept untwisting and untwisting, so I had to keep it in an empty room with no movement from period 1 to 3 on a school day. That's 9 to 1:30. In the end, I got an average value of 4.09 times 10 to the power of minus 8, compared to the accepted value, 6.67 times 10 to the power of negative 11. So I almost got there. Thank you for watching.